This is Graphing Rational Functions Day 4, and today we're actually going to do our first slant asymptote. So first one, we're going to factor and cancel. See how this one turns out. On the top, I've got x and x. The only way to multiply to 2 is with a 2 and a 1. To get to a negative 1 right here, my 2 would have to be negative and my 1 positive. So nothing's going to cancel. Kind of a bummer. No holes. So vertical asymptote is when denominator equals 0. So if I set that equal to 0, I would get a 1. Horizontal asymptotes, we ask where the highest power of x is. Since I didn't cancel anything, I could look back here. So highest power is on top. If I wanted to look here, you just have to remember to put both of these x's together. So that's an x squared on top of an x. So top is bigger, so then you don't have any. If you've decided that your numerator is bigger than the bottom, then you have a slant asymptote. So this is our first slant asymptote. And if you look at your blue card, it only happens when the top is bigger than the bottom. And there's a little caveat there, dividing by 1 doesn't count. So what I mean by that is if we had like x squared plus 2x over 1, we wouldn't say that the top is bigger than the bottom. Like having a 1 down there doesn't count in terms of comparing power. So what we're going to do is divide. In this case, we could synthetically divide, which is totally fine. Remember, long division works all of the time, but I'll just synthetically divide this one up here in the corner. So I'll put a 1 in the corner because that's what we're dividing by. And then I've got a 1, a negative 1, and a negative 2. Draw a line. I'll drop the 1 down, times by 1, 0, another 0, and then negative 2. Not necessarily looking for 0 for a remainder, but I don't have to worry about the remainder. My blue card says that you can just ignore the remainder, whatever you get. What you're focused on is what you got either on top of the divisor or what you got for an answer in synthetically dividing. So this was an x squared. It's now just an x plus 0. So the equation of my slant is y equals x. And that looks like this. It just goes straight diagonal in both directions. There's my slant. Next up, my x-intercepts happen when the numerator equals 0, and I've got two things up there, so it looks like I'm going to have 2, 0 as one of my x-intercepts, and the other one's going to be a negative 1, 0. So 2, 0, and then negative 1, 0. Y-intercept, plug a 0 in for all the x's, so a 0 squared and then a 0, so those go away. I just have negative 2. And then on the bottom, I've got a 0 minus 1, so that's just negative 1, so my y-intercept happens at 2. Sorry, I should have made that be a point. There we go. And then we'll graph it, and then we'll do our domain and range. So what's nice is you've already got points on both sides of your vertical asymptote, so that's pretty awesome. If I connect these and try and get close to the asymptotes, I'm kind of forced in that direction. Same here. As soon as you try to get close to the asymptote, you're kind of just forced to go in both of those directions. It's a pretty great graph. I don't have to check anything else, because if you were, I'm going to do this in pencil, if you somehow like graphed something here, number one, it would need a y-intercept. You only get to have one of those, and you already used it. Also, if you put something here, it fails the vertical line test, so it wouldn't be a function. And then same goes for if you were to do the same thing up here. If you put a chunk up there, or you decided there was something up there, it would fail the vertical line test right away. This wouldn't be a function. So the two pieces that we found are sufficient, and they are the function for this graph. Domain, again, this one will be the easy one to figure out. X cannot be just the vertical asymptote. You didn't have any holes, so you don't have to worry about that. Range for this one, again, this one will be a little bit easier since both of our lines go down and up forever, so our range is all real numbers. Sometimes when you have a slant, maybe it's the next one I forgot, but you could have bubbles like this where you can't quite tell what the highest place is, so it'll kind of be like in the previous lesson where we had the two vertical lines and then we had that parabola in the middle where we don't quite know where that highest point is, but we'll do our best to give it a guess. All right, so let's do one more. Looks like on top I can't factor that, but I could take out an x, and then they would have an x minus 1 on top, x plus 1 on the bottom, so nothing cancels, no holes. Vertical asymptote is when the bottom equals 0, so that will be negative 1. And then horizontal asymptotes where the highest power of x is. There are two x's on top and only one on the bottom. Since I didn't cancel, I could just look at this. Highest power is in the top, so no HA, that means I have an SA. So we're just going to divide it. I can do synthetic again since I'm dividing by a simple divisor, so -1, and then I've got a 1 and a -1 and technically a 0 for that last term. Drop the 1 down, times by 1, and then times again, and then add. And remember, we don't care about the remainder, we just care about this equation. We started off as an x squared, so now we're just an x minus 2, so there's my equation for my slant, y equals x minus 2. And that's just a regular old like line, y equals mx plus b, so this is my b, -2. Slope is 1 over 1, so I'm just going to go up 1 over 1, put some dots down so I can connect. And this is an asymptote, so dot that. And then let's go after our intercepts. So an x-intercept happens when the numerator equals 0. You have two of them up there, 0 and +1. +1. And then y-intercept happens when you put zeros in for all the x's. So 0 times anything is just 0. On the bottom, 0 plus 1 is 1, but it doesn't matter because that's just going to be 0, 0. So I've got 1 point right there, and then I've got another one right here. So there's some kind of bump right there, and then I head out to find my asymptotes, and then we have to find the other chunk. Remember, you're always looking on sides of the vertical asymptotes, so I don't want to try a point over here because it's just going to end up being on this part. So we need to try a point over on this side, so I'm just going to try -2. And I'm going to plug a -2 in, so I've got -2 on top, and -2 minus 1, and then -2 plus 1. So -2 times -3, and then -1 on the bottom, so it looks like this will be -6. So -2, -6, that's down here, so that means we're kind of looking like that. There is my slant asymptote with my graph. So there's kind of two options that happen. Either you have these two pieces that kind of skirt the outsides, or you have the two that are kind of in the corners, and they're kind of confined to almost these kind of sideways parabola-ish type shapes. Domain, again, will always be the easy one. It's just not your VAs. So -1, I didn't have any holes this time. Ranges, this time it's going to be one of those tricky ones. So I would just say -infinity up to about, I'm just going to say -6. It's somewhere in there. Remember, we're not going to get too antsy or specific about it. And then we're going to pick it up. It's definitely negative because I can't connect these without coming down into the negative side. So I'm just going to say about -0.5. And then it's going to go all the way up to infinity. So just working on at least chunking these up into two pieces, like this one has to end and then this one has to start. And really you're just kind of giving this a guess because we're not going to, at this time we're not going to go and get specific about where those are located, how high or low they go.